Good morning, distinguished guests, ladies and gentlemen. Welcome all of you to the air pollution and transportation sector, opportunities and challenges in Vietnam and elsewhere panel, a Science for Life Symposium today. One more time, thank you very much for being here with us in this event. Ladies and gentlemen, the VinFuture Prize is a prestigious global award committed to advancing science and technology for humanity. The VinFuture Prize 2024, with the central theme, Resilient Rebound, seeks innovations addressing urgent global challenges like climate change, healthcare crisis, and resource shortages, driving sustainable development. The topics we'll explore in today's panel are essential for advancing global scientific progress and have profound implications for human life. Air pollution is a serious global challenge, heavily impacted by transportation sector, which contributes significantly to poor urban air quality. Vietnam is working towards the ambitious goal of achieving safe air quality levels by 2030. Transitioning to cleaner transportation such as electric vehicles offers a vital opportunities to reduce pollutions, improve the public health, and promote sustainable development, and to disseminate scientific and technological knowledge to the public and connect generations of young scientists, inventors, and entrepreneurs with globally established inventors for potential partnerships. And this event is held with the participation of distinguished speakers who have excellent expertise and experience in the field of atmospheric science and sustainability. And to come to the event today, we would love to welcome many representatives working in the field of science, technology, and also from government. We would love to welcome Professor Sir Richard Henry Friend, Chair of VinFuture Prize Council. Welcome, sir. We are honored to have Dr. Lê Thái Hà, Managing Director of VinFuture Foundation. We are honored to welcome Professor Susan Solomon from Massachusetts Institute of Technology, the 2018 Crayford Prize and 2023 VinFuture Special Prize Laureate, and also the member of the VinFuture Prize Council since year. Will serve as the chair of this morning's panel. Welcome all of our distinguished guests. And now, ladies and gentlemen, let's take a moment to introduce today's symposium topic and get acquainted with our chair and distinguished speakers through a brief video. So now, video please.
The world is grappling with one of its greatest challenges, air pollution. According to the World Health Organization, 99% of the global population breathes air that exceeds pollution limits, leading to 7 million deaths annually. Transport-related emissions are a major source of nitrogen oxides, particulate matter, and hydrocarbons, driving ground-level ozone formation that causes respiratory diseases and premature death. Additionally, black carbon in particulate matter acts as a short-lived pollutant with immediate adverse climate impacts. The global vehicle fleet is set to multiply 3- to 4-fold in the next few decades, with most of this growth set to occur in developing countries. Efforts to tackle this crisis are centered on deploying advanced air quality monitoring, conducting rigorous emissions inventories, and driving a large-scale transition to electric vehicles. Together, they aim to slash harmful emissions and push forward groundbreaking innovations in clean technology, compelling industries and governments to align with urgent climate goals and sustainable development. Let us seek insights from prominent experts and visionaries who will shed light on how this transformation will work in this symposium. The chair of the symposium is Professor Susan Solomon from Massachusetts Institute of Technology, the 2018 Crayford Prize and 2023 VinFuture Special Prize Laureate, member of the VinFuture Prize Council. Also featured in the symposium is Professor Yafang Cheng from Max Planck Institute for Chemistry, Director of Department of Aerosol Chemistry. Associate Professor Quoc Bang Ho from Vietnam National University Ho Chi Minh City, Director of Air Pollution and Climate Change Research Center. Professor Daniel Kamen at University of California, Berkeley, and member of the VinFuture Prize Council, Senior Advisor for Energy Innovation at the U.S. Agency for International Development. Under the theme Resilient Rebound of the VinFuture Prize Award Ceremony 2024, this symposium will highlight the latest advancements in air quality control and clean transportation, offering nations like Vietnam the opportunity to adopt sustainable practices. Join us to contribute to a better world.
Thank you very much, distinguished guests, ladies and gentlemen, for your attention on our introduction video about our topics today. And now, please join me in welcoming to the stage Professor Susan Solomon, Lee and Geraldine Martin Professor of Environmental Studies, and also the chair of the program in Atmospheres, Oceans and Climate at the Massachusetts Institute of Technology, USA, member of the VinFuture Prize Council, 2023 VinFuture Special Prize Laureate, and also the chair of today's symposium to deliver the introduction about our topics. So, Professor, please, the stage is yours.
Well, thank you so much. Thank you so much for coming. It's a real pleasure to be here in Hanoi and to have the chance to talk about this extremely important problem for Vietnam and for the world, really. It's an issue that societies have grappled with for decades. A lot has been learned about how to control air pollution, and a lot has been learned about how damaging air pollution actually is to public health. It kills millions of people worldwide every year, and this is something that is both tragic and to some extent avoidable. So we really are excited to have a chance to talk about how air pollution problems in Vietnam and elsewhere might be avoided in the future. So without further ado, I guess maybe I should say one more thing about this slide. I think that one of the ways that is always helpful in looking at an environmental problem is to ask the question, how has this issue been dealt with in other places? Are there case studies of dealing with air pollution in Europe, the United States, other parts of the world that give us clues for what we might do here in Vietnam? So that's the theme of the way that we are structuring this. And we'll start with Professor Ho, who I think is a wonderful person to present the local context for us. He'll talk about where emissions are coming from. Is it trucks? Is it cars? Is it motorcycles? How do these things contribute? And what opportunities exist for co-benefits if you reduce air pollution? Do you also get a benefit for reducing climate change, which then, of course, can link into the Paris Agreement? And then we'll hear from Professor Yafeng Chang. I'm so honored that she was able to join us here from Germany. She's a director of a Max Planck Institute, which is going to do some really exciting work on aerosols. It's the little aerosol particles that cause most of the human health effects. And she'll talk about examples of the chemistry that creates those aerosols and makes them so damaging for public health, and of course also for the health of animals and plants and the entire ecosystem. And she'll show us some case studies. And then we'll hear from Professor Kamen on how the urban air pollution might be addressed. And he'll give us some examples, I think, of some success stories and discuss the implementation mechanisms that have been useful in developed and developing countries. So I am incredibly grateful to all of these folks for spending their time with us this morning. And without further ado, I'd like to turn it over to our first speaker, which would be Professor Ho. Thank you. Professor Ho, please.
Thank you very much, Professor Susan Solomon, for your amazing introduction. And now, we would like to introduce to the stage Associate Professor Quốc Bằng Hồ, Director of Air Pollution and Climate Change Research Center at the Institute of Environment and Resources, Vietnam National University, Ho Chi Minh City, Vietnam, for the first presentation on sources of air pollution in Hanoi and Ho Chi Minh City. So, Professor, please.
Ladies and gentlemen, good morning. So today I would like to present very quickly the source of air pollution in Hanoi and Ho Chi Minh City. That's the two big cities in Vietnam. So on behalf of our team, we have a Joyka here. So Dr. Fukodai, our co-author here. So just a little bit about the SBI NDC project. This project, we work with Ministry of National Resources and Environment Monterey, Vietnam, to support for aligning with Paris Agreement. And for that, we work with 3 different levels. We work with national level for GHG reporting system for whole the country, and also work with different sectors like transportation, like industry, etc. And in this part, we do air emission inventory and assessment of NDC. And the last one, we work with different private sector, with company, to support them for calculating the greenhouse gas for different sector to be net zero in 2050. For that, the first one, I would like to introduce about the source of air pollution in Hanoi City. So you can see that this is some information overview. Because we calculate emission for Hanoi in 2022, that's a reference year. That's why I put all the information here that for 2022. And you see that a lot of private vehicle, more than 6 million of motorcycle, and also we have around 2,000 different factories have air emission. And also air in Hanoi and in Ho Chi Minh City are polluted by some pollutant and some hour and some location also. Here the show of air pollution in Hanoi City. So you can see that the different sources we divide into 3 different sources: light sources, area source, and point sources. It's industry. So for light source, you can see almost high emission in contribution in Hanoi for light source from road traffic. And the next one for SO2, that's from industry source. And the rest for the area source. Area source, we have biomass burning, rice crop burning, and household cooking, etc. And here I want to show you very detailed, very detailed for the source for each pollutant. You see that only motorcycle, 6 million of motorcycle in Hanoi City contribute about 36% of total NOx in Hanoi. And also for another pollutant. For PM2.5, it's very critical pollutant that everyone, they talk about air pollution and mention about PM2.5. Heavy truck contribute around 40%, cars 16%, buses, biomass burning, motorcycle, and household cooking. So you can see very detailed of the source in Hanoi City. And how about Ho Chi Minh City? Ho Chi Minh City also is the largest city in Vietnam with more than 9 million inhabitants now. And we have around 8 million of private vehicle. We have a lot of factory also, 2,700 factory having air emission. This is the location of industry factory around the city. So here, that's the source of air pollution in Ho Chi Minh City. You can see here, we also divide into 3 different sources. NOx, CO, and some like methane, it comes from the traffic source, but almost from motorcycle. And some pollutant that from industry source. And here, and here you can see that the different amount of air emission for different sources. Industry also contribute high emission in Ho Chi Minh City, like SO2 more than 52%, BM 2.5 around 46%. Yeah. For that, I would like to go conclusion that we apply a bottom-up and top-down approach to calculate air emission for two cities, and also for Hanoi, traffic should also the large emission for some pollutant, except SO2 industry contribute about 40%. For Ho Chi Minh City, motorcycle is also the main emission because we still use a lot of gasoline motorcycle and very high contribution of emission. And in the session one, next step, I will present very detailed for two cities on air pollution. For that, I would like to thank you for your listening.
Thank you very much, Associate Professor Quốc Bằng Ho, for your informative speech. And now it's time for us to welcome to the stage Professor Yafang Cheng, Director of Department of Aerosol Chemistry at the Max and Planck Institute for Chemistry, Germany, to deliver the presentation of Urban Haze Formation, the role of chemistry in aerosol water and black carbon. So now is your time.
Yeah. Thank you all very much, and thanks for the VinFuture Foundation, and thanks for Professor Susan Solomon and everybody here for giving me this opportunity. I'm really grateful to share our study and also our experiences in air pollution control. So today I want to talk about the urban haze formation. What is the chemistry in aerosol water and how is the role of black carbon? So, take a deep breath. So, it is almost certain that in this moment, you inhale like tens of thousands or even millions of tiny, small, solid particles, or if it's outside or live in some liquid droplets. So, that's why all those tiny, small aerosol particles, tiny, small specks of matters is known as aerosols. So that's what we are studying. And every one of us breathes 11,000 liter air per day. So that's why it is almost inevitable that particulate matter suspended in the air is highly relevant for human health. And it has been ranked as the top 2 health risks for globally. And you can see it has already shown for strong influence on the premature death, the mortality over vast area of the continent. And when you look at this number, up to 9 million premature deaths caused by aerosol pollution in 2019. I want to put this number, this is a risk assessment. So it's not really a cause, but it's a risk assessment. But when you look at this number and think about in the 3 years of COVID, the COVID caused only up to 7 million deaths for the whole 3 years. But the air pollution, aerosol pollution in 2019 in 1 year has already put 9 million premature deaths in a risk. So this means it's really a huge problem that we need to deal with globally. And aerosol particles, they also can interact with solar radiation. So they can scatter or absorbing lights. So in turn, cooling or heating the earth. So it is also can modify the clouds. And according to the latest IPCC, aerosols remain one of the largest uncertainty in climate assessment. It is also those tiny aerosol particles that makes many cities look so different during haze time and blue sky. So this is what we are studying is the aerosols. And the emission sectors, the emission from the transport sectors, for example, the NOx and also black carbon and others, they contribute to urban haze formations. And I want to share is what we have learned from the air pollution control in China, what is the role of NOx and also black carbons, which are largely emitted from the transport sectors? So the severe winter haze shrouding Beijing that recalls the London killer smoke, actually. And already in 2015, Beijing issued its first air quality red alert. So this urged the need of effective control strategies. So we are not only want to control, we want to effectively control this thing. And of course, we can simply cut the primary emissions. So whatever, you just cut it. Then you will get clean air, I think probably in 1 week or 2 weeks. But that's not what we want. We want to do it cost effectively. And what can we do more is that we know that the secondary aerosol formation, which is the conversion from the gas pollutants to the aerosols, that globally can contribute up to 80% or more of the aerosols suspended in the air. So of course, we think that it could be more efficient if we can cut here. But the question is how? To cut here, we need to understand the haze chemistry. But this is not easy because in Beijing, in 2013, in the worst case, the sulfate aerosols in the atmosphere can go up to 300 microgram per cubic meter, and the total PM2.5 can go up to 1,000 microgram per cubic meters. So, but even for this very simple, looks like sulfate, we are not fully understand how it's formed in an urban environment. Because conventionally, we believe that in the urban environment, the sulfate is formed from the oxidation of SO2 by OH radicals. With this mechanisms, you can imagine when you have more aerosols, see here, you will have, if you have more aerosols, because of the aerosol dimming effects, you will have lower OH radicals. That's why you expect a reduced sulfate formation if you have more aerosols. But in reality, we see that the sulfate formation rate actually increases with increasing aerosol concentrations. So this is not following this traditional mechanisms. So it seems that it doesn't work. Yeah. So this is expectations. And this is in reality. So this means we have a missing oxidation pathways that we don't know how it forms. So even with the cloud chemistry included, in the severe haze event, the model can explain only 10 to 20% of what we have observed. And when we look at this, searching for this missing source, and we found that the missing source shown here as the difference between observation and model of sulfate follow very nicely with the aerosol droplet content. So this means the aerosol droplet, the aerosol water, there may be some chemistry going on here. And it turns out that the reactive nitrogen chemistry, which means the aerosol droplet can serve as the reaction bed, and then the alkaline aerosol content trap the SO2, and it can be oxidized by NO2 to form the sulfate in the haze. So we can see here that this reaction, this red circle here, can largely explain the missing source, the white diamond, and which will exceed like orders of magnitude of the photochemistry in the severe haze events. And unlike the photochemistry, that is negative feedback, when you have more aerosol, then you slow down the reaction. The reaction in aerosol water is actually positive feedback. So if you have more aerosol, you have faster the reaction and you build up more pollutions. So that's why we need to stop this. And So in this case, we know that with science-oriented emission control, for example, to cut down the NOx emission, will not only reduce the nitrate, but also reduce the sulfate. So with this way, we can stop or block this oxidation pathways here. And another thing, we are curious why haze more often happened in the winter time. This is not only chemistry or emission is playing a role there. Also, the meteorology will play a role. Because in the winter time, you have low boundary layer development, which means in the unfavorable conditions, the emitted pollutants cannot disperse very quickly, so they build up in the boundary layers. But the aerosols in the boundary layer can even worse this, because it will shed the light, so you have less energy to develop the boundary layer. And when you have kind of scattering aerosols like sulfate, nitrate, and sea salt, and most of the organics, you see when the aerosol concentration increase, here indicated by the aerosol optical depths, the buildup of the boundary layer can gradually decrease because you don't have enough energy, incoming solar radiation energy. But when you have black carbon, which is absorbing aerosols, this evolution will change like this. So it means if you have 15% of PM2.5, which is black carbon, then your boundary layer, if you increase the total aerosol concentration, the boundary layer development will suddenly drop. So even during the daytime, you can have boundary layer that is lower than 100 meters, which means it's almost mimic the nighttime. And you have very, very, very unfavorable conditions to build up air pollution very quickly. And why it is like that? So when you look at the heat exchange coefficient, you see when you have black carbons, you have mixing here and also mixing close to the surface. But when you increase the aerosol concentrations, the upper part is still mixing, but the lower part gets reduced. And at some point, these two parts will decouple. So this means you will build up potential temperature vertical profile, which is then build up very, very low boundary layers and causing this effect. So when we plot here, you also can see the decoupled mixing layers. And when you look at these two, you also see that this is an impact of black carbon absorbing aerosols. So when you have only scattering aerosols, it's gradually decreased. But when you have absorbing aerosols with black carbon, if you reach this threshold, then the boundary layer will suddenly drop. And how is this telling us with emission control? So because this dropping critical aerosol concentration is actually a function of how much black carbon in your aerosols. So when you plot this aerosol concentrations as aerosol optical depths and single scattering albedos, so you see if you want to control, if you don't want this sudden drop of the boundary layer, you want to reduce your aerosols, but you also don't want to reduce it very efficiently. So this means you can go this way, which means you reduce everything, including black carbon, but also scattering particles. You need to reduce a lot. But if you increase the single scattering albedo, which means you reduce just black carbon or heavy diesel cars or so, then you become very efficient. So which is, in Beijing case, in winter, can be 5 times more efficient to remain the boundary layer development. So this is why to reduce black carbon, which is also a climate warming agent, is very urgently needed. Yeah, so here we show it again that if you have these two mixing layer coupled, you still can have a boundary layer full development. But if you have these two layers decoupled, you will have a very low boundary layer, which is unfavorable and build up a lot of pollutions. So I think for air pollution control, our experience is that you need to observe because particles are very tiny. It's formed from gas phase through nanometers all the way to micrometers. So you really need cutting-edge instrument development and also 3D field observation and monitoring networks. We are also using multi-scale modeling, actually all the way from molecular dynamic or quantum chemistry to the global simulations, and also with AI and machine learning in it. We also need satellite to have a global view. And in this way, if we could have a synergy of all of that, I think we could finally have a path towards a global solutions. Yeah, thank you very much.
Thank you very much, Professor Yafang Chen, for your insightful speech and presentation. Distinguished guests, ladies and gentlemen, in the symposium today, we are honored to welcome an impactful scientist, Professor Daniel Kamen, James and Catherine Lau, Distinguished Professor of Sustainability at the University of California, Berkeley, USA, Senior Advisor for Energy and Innovation at the U.S. Agency for International Development, and also the member of the VinFuture Prize Council. And now, he will deliver the lecture of Interdisciplinary Action on Air Pollution, Solution Science for Climate Health and Social Justice. Thank you very much, and now, Professor, the stage is yours.
Well, thank you so much, and thank you all for being here. Thank you to the Vin Prize Council, to our colleagues, and to Susan for organizing us to talk about not only the challenges, but also the degree to which we need to accelerate solutions that meet a range of goals. And so while I'll talk about the impacts of air pollution, what I'll really be trying to focus on is how do we accelerate the agenda of transformation a little more broadly. And so, one of the points where Susan and I connected is in the IPCC, the Intergovernmental Panel on Climate Change, where the consensus approach on what level of reductions we're going to need has been highlighted again and again, and I feel like the scientists in the room feel like we have been talking and retalking a known story. What I won't do is to detail the clear difference between the pathway we're on, the current policies that took a step backward, I would argue, at COP29 in Baku, that would limit warming to only 3 degrees. There are some pessimists that think 4 or more, compared to the pathway of 1.5 that the international group of scientists has endorsed. So we not only need transformative solutions, we need those that work across domains because we are simply not making sufficient progress. And so the slide you saw about air quality, I think everyone needs to, what is the most visceral version of that story? Certainly New York City on a clear day, 2 days later, when the fires in Ontario, in Quebec, turned it into a scene out of a science fiction movie. And in fact, real world was a little worse than the Blade Runner science fiction story. So again, whatever metaphor, whatever image is most clear, for me, the one that I keep coming back to, however, is that as dire is the climate story, we climate scientists have so far largely failed to translate that into actions that everyone gets on board with. And yes, there's a broad anti-science movement right now. It's certainly taking place in certain parts of the US. But one way to think about it is the Sustainable Development Goals, as imperfect as they are, 17 different metrics, all of which are valuable in their own set. Energy access for all, that's SDG 7. We're about 700 million people without access to electricity. Equitable access to education between boys and girls, food, preserving the landscape, all of these are valuable. And yet a snapshot of what we're doing in terms of these UN agreed goals is a horrific mixture of a few little successes, but broad failure. All the red shows negative progress towards our 2030 goals. So that is in keeping with what you've heard so far about how dangerous and how troubling things are. What I'm going to highlight, though, is, I guess, what I would call the irrational optimism or exuberance of what we can do to change that. And our strongest tool in that picture so far on the technical side, not on the social and justice side, which we'll come to in a bit, is the fact that while the author got it wrong, these are not S-curves, S and exponential are not the same, but the remarkable growth where costs of solar and batteries have declined by 90% in the last decade, offshore wind by 60%, and the majority of new energy installations now are renewables worldwide. That is not sufficient. That's an amazing starting ground, but insufficient to get us where we need to go. And in fact, if we talk about the so-called Moore's Law or learning curve, showing that every time we double the deployment of new technologies, not just clean energy, but many of them, what we observe is about a 20% drop in price. Economists will disagree whether this is a law or not, but in terms of technology innovation, it is something you can bank on. As you can see, for decades, we've achieved and maintained that process that largely follows this power law relationship. So that's the good news. And what the good news says is that in a world where we were not subsidizing poison, which we are, it is now cheaper to build clean energy power plants than it is to operate existing fossil plants. And I know even CEOs of companies with significant renewable energy investments that see this has been published since now 3 years, don't seem to believe it or act on it, largely because we subsidize fossil fuels more than 5 times our current annual expenditure on clean energy. So we are far out of balance to make these transitions happen. In my state of California, we now generate enough renewable energy so that we can meet our average demand for energy with solar, geothermal, and wind power alone. Over the last 100 days, we have exported clean energy to our neighboring states. But of course, we have this thing called nighttime, and we do not have an ideal wind resource. So adding storage, the batteries you see here, is filling in the wings, getting us closer and closer towards being able to talk about renewables as a baseload or 24/7 source of energy. It's a remarkable achievement in the world's 5th largest economy, but it's far from meeting the goals of social, racial, and gender justice. And it's this balance between clean energy implementation and meeting these wider sustainable development goals that we need to put into action. Just to highlight how dramatic the opportunity is that we're barely capitalizing on, for the economists in the room, you can see here, these are batteries from large-scale industrial facilities to small ones in the garage of homes like mine, where they're charging up wherever you see that fuchsia or pink color, and discharging when the market prices are high, i.e. we are now arbitraging clean energy, so much so that at the right time of day, 5 p.m., for example, when we have excellent sun, in many parts of the U.S., excellent wind, the price of energy now can go negative because of the role of renewables. So it's a remarkable step forward. One of the things we need to do is to make the tools open access, and yesterday we had the discussion about machine learning and AI and the degree to which utilities and companies and nonprofit groups and racial environmental justice groups all need access to the same data. Some of the work that we've done in Kenya, in Japan, in looking at what it will take in terms of deploying clean energy to meet these goals is part of the story. In my laboratory, along with many others, partners at University College London, partners at University of Nairobi, partners at University of Kyoto, a number working on these areas. And so these are some of the countries that my laboratory has provided these models and worked with the government on their clean energy deployment strategies. That's a great start, but it's nowhere near enough. And so one of the things I wanted to thank the VIN group for is that they've donated some of their electric vehicles to our laboratory. There are some of our students doing some deployment projects. And just to highlight some of the opportunities that tie what you heard in the first talks to this one, a air quality monitoring network set up across the San Francisco Bay Area has already detected a dramatic drop in air quality, just about a 2% per year drop, directly attributable to electric vehicles, so much so that we are now seeing the air cleaning because of our clean electricity powering a fleet of almost 2 million electric vehicles. California after the UK, and both of us far trailing China. China has about 23 million EVs in use, UK about 2.7 million, California about 2 million, are deploying at a fast rate, but not necessarily doing so in a way that promotes justice. And so while this is the first dramatic data showing that this transition really does clean the air, we need to push much more quickly. And if those subsidies weren't in place for fossil, the very simple economics, the very simple energy analysis that an electric vehicle provides about 90% of the energy that comes to it to move the vehicle, as opposed to 15 to 25% of the incident energy from a fossil fuel vehicle. Dramatic opportunities that we need to push forward in the process. A former petroleum station in California now switching to electric vehicle charging, a whole range of important and dramatic opportunities, but we need to translate those into policy. And so closing few seconds, some of the work that we've done working with state legislatures is to highlight the degree to which, even if we push for electric vehicles, if we don't make charging available to low-income individuals worldwide, we basically do a good for climate but regressive for society approach. So highlighting that in many parts of the world, high prices mean that the poorest people drive the furthest, even if they could access electric vehicles. We got our governor to sign the world's first agreement to end the sale of new gas-powered vehicles by 2035. Massachusetts, the Netherlands, and the UK looked at that and said, we can do better, we can do that by 2030. California is now rushing to catch up. And now we have a process where, working with ride-sharing vehicles and other fleets, we're able to push these technologies much more broadly, because in many parts of the world, operators of rideshare vehicles are some of the lowest income individuals, new immigrants. It's an opportunity to build access to clean energy vehicles, to push the clean energy deployment program in a way that marries together the climate story and social justice. So I'll stop there. I hope that wasn't too quick, but that it illustrated some of the opportunities to work both on the material science, the technology side, but also to accelerate that for which we're failing at, and that is pushing this to deployment at a speed that's even slightly commensurate with what we need for our climate goals. So thank you very much for the time to talk with you today. Sure enough.
Thank you very much, Professor Daniel Kammen. And could you please turn back to the stage? So now we will come into the discussion panel today, and we would like to welcome back to the stage Professor Susan Solomon, Professor Yafang Chen, and Associate Professor Guok Bang Ho to join the symposium's panels today. Could you please kindly give a round of applause to our panelists today with the discussion panel about our topic. So panelists, it is a time for the discussion.
It is what it is.
Well, thank you. Wasn't that wonderful? Let's have another round of applause for all our speakers. Great. So I guess I have a few questions, and then I'd like to see what some of the audience questions are. By the way, does anybody else have a little tickle at the back of their throat today? We have so much air pollution out there. If you have a look at, at an angle, you'll see this incredible stuff. It's not really fog, I don't think. It's actually smog. Is that true, do you think, Yafang? Everybody says, yeah, okay. How much worse can it get on a really bad day in Hanoi compared to today? How many times more particles do you think we would have than what we probably have now? Factor of 10, factor of 50?
For PM2.5 reduction, I think that should be reduced factor of 3 for Ho Chi Minh City and about 4 to 5 for Hanoi City. It depends on the city. Yeah.
Yeah, okay, interesting. How related is it to the weather type of phenomena that Yafeng talked about for Beijing? Do you have a sense of what the weather needs to be like in Hanoi for the air pollution to get particularly annoying?
Yes, actually, the air pollution comes from two main causes. First, from emission source. Second, should be from the weather factor.
Yeah.
So for Hanoi City, the weather factor is very important because as Professor Chen just mentioned that the inversion thermic layer. So in Hanoi happens regularly and very low altitude, so that the air is trapped in the ground level. And then that's why the air pollution in Hanoi is high than in Ho Chi Minh City. Even the air emission in Ho Chi Minh City more than in Hanoi because we have more sources. But the weather in Ho Chi Minh City is easy for air dispersion because we have a lot of sun and very hot weather. So that's good for air dispersion. Thank you.
Do you think you ever get the kind of collapse of the boundary layer that Professor Chang talked about? Do you think it's the air pollution ever gets intense enough here that it causes the collapse of the boundary layer? Do we know if that happens here?
Actually, we didn't study detail on that kind of the research like Professor Chen. Yeah.
What do you think? Do you think that could happen in this climate?
I think if it's 3 or 4 times worse than now, I think it could happen.
Yeah, I would think so.
Yeah, because it depends on how much black carbon in the air. It also depends on the seasons. So if you have less solar radiation, for example, in winter time, it will happen more easily. And also, I think the picture that I showed for Ho Chi Minh City, it's actually a combination of PM2.5 pollution and also fogs. I think if I don't know if in Ho Chi Minh, in Hanoi or Ho Chi Minh City, there are fog or something happen regularly, because the reaction that can happen in aerosol water can happen in fog too, and much more efficient. So yeah. And once the fog evaporates, it then becomes PM2.5 for dry particles also.
So if we talk about problems in Vietnam, I mean, it was very interesting, your analysis of trucks and motorcycles and cars. Is it the same in different cities around Vietnam? Do you think some cities have more of an issue with trucks and others have more of an issue with motorcycles, or is it always similar?
Yes, actually in Vietnam we have 63 provinces and cities. So they have a different the emission pattern. So up to now I did the air emission inventory for 12 cities from northern, central Vietnam and southern Vietnam. So they are very different. It depends on the economic development. Like in Hanoi, Ho Chi Minh City, we have more traffic source. But like in Bà Rịa Vũng Tàu, Đồng Nai and Bình Dương, is in the southern Vietnam, like they have more industry. That's why the emission is different. Yeah, very different from city to city. However, in general, the traffic is the most contribution in the province city in Vietnam, at my experiences. Thank you.
So I'm going to ask each of the panelists, if you could change just one thing, what would that one thing be to improve Vietnamese air pollution? You just get to change one thing. You can't change two things. What's the one thing? I'll start with you, Dan. What do you think?
Well, so not being a Vietnam expert, I'll take a bit of a more macro, and that would be something I said very briefly, which is that we effectively encourage individuals and companies to pollute by not having, and I'm not an economist, I'm a physicist, but by not having a price on pollution, we are telling companies, please use the water, use the air. And so the market prices of carbon around the planet are woefully low compared to the damage they're doing on ecosystems and on human health. So I would say adopting what's called a social cost of carbon, which is more than 10 times the price of carbon pollution anywhere in the world except for Sweden, would be my starting option, which is going to be challenging politically, but if we're going to take this problem on, we're going to have to take it on at scale.
Do you think that the European border mechanism that's about to come into effect has any potential to start that process?
I do not. Sadly, I don't, because pollution is a global problem and doesn't understand borders and doesn't listen to borders. And what we've already seen are companies shifting around to take advantage. And if there is a pollution opportunity or hotspot, the private sector is very good at finding it until we think about broader solutions. So I'm not against it, but it's about like rearranging the deck chairs on the Titanic.
Well, I mean, I don't know. I guess I would maybe beg to differ a little bit. First, maybe we say a little bit about what it is. So what it is a tax on anybody who wants to sell steel or aluminum to Europe is going to have to pay a border tax if their use of carbon to produce that steel or aluminum is higher than it would have been within Europe. That's my understanding of how it works.
Right, no, I said I'm not against it, but for example, Europe for decades has been giving credit for biomass, for biofuel, as a carbon neutral product.
Wow.
And they are importing that biomass from Malaysia and from the US South, and it's causing huge environmental damage in the source areas. And so we can't rearrange the chairs without recognizing we're all in it together. And we seem to be having a hard time acting collectively these days.
True, and biomass is a particularly bad example, as
Well,
you
that's
know.
why I chose it.
But there's other ways that you could imagine producing steel with less carbon emission, like hydrogen, for example. Wouldn't be a bad way. All right, well, I think we probably, can ask now Professor Chang, if you could change one thing, what would it be to improve air pollution here in Vietnam?
Yeah, I guess maybe I'm not talking about changing, but more of improving. So I guess we are caring about our climate. We care about our environment. It is not only climate, like yesterday, the plastic. It's also a huge problem. But I think we also care about the daily life of everybody. So I hope that we could be in the climate and environmental science, that people can invest. When you have money, you have funding, you can invest more on the technology improvement, and also be more open to everybody of those technology that can make the green energy, the clean energy, that it's cheap enough that everybody can use it, can afford it. So there, I want to make an example that it's in China, the residential part of those people who is not living in a very good condition, it costs around 7% of the energy consumption, but it costs 65 or 60, more than 65 of the indoor air exposure. So this means we need to improve those people's can be able to afford and using the clean energy, which means we need to work, as a scientist, work harder to improve the technology and also be more open to share it with Global South so they don't need to pollute, but at the same time, they can improve their economy, I think.
Okay. I fully agree with you, and I would hope that something like that could happen over time. It's just that, of course, in developing countries, we need a little more help from developed countries to make sure that that happens. So, you know, if I had a magic wand to wave, I would say to do a more comprehensive job of including air pollution in the Paris Agreement as a method for improving both the greenhouse gas emission and the air pollution impacts in developing countries.
Yeah.
As I agree with you that Baku didn't deliver everything we wanted, but still it delivered some kind of promise of an increase in aid, which I think will be very helpful, depending on the nature of the aid, of course.
Although developing nations were asking for 1.3 trillion by 2035 and got a promise of 300 billion, and some of that is actually dependent on the private sector doing things they've never done in the past.
Right, and some of it is loans from the World Bank, and you know that's a problem too, but yeah. Okay. Professor Ho, your turn. The one thing, just one thing.
Sorry, I can have a three?
Maybe two.
Very quick. So, because as I mentioned that we have three different sources. For me, the first one for traffic, we buy an electric vehicle.
Yeah.
Because we did a lot of detailed research. I will show you in the session one later. We assessment the impact of the electric vehicle on the air pollution and co-benefit with greenhouse gas. Then we have a very clear evidence and convince people use electric vehicle. That's for traffic. For the industry source, khói source. So we need to have the tax for emission, air emission. Because until now we don't have the dust tax. Then we control the company to reduce emission. And for people, for the citizen, we would like to forecast air pollution in next 24, 48 hours. To protect for people's health. Because until now we don't have that information, then it's not easy to raise awareness of people on protecting their health.
That's a very good point.
That I would like to do priority for the air pollution in some cities in Vietnam. Thank you.
So in terms of electric vehicles, when you say vehicles, which one would you do first? Trucks, cars, motorcycles?
We go first with the motorcycle.
Yeah, because there's so many.
Second is with the cars, and then the buses.
Yeah.
Like the last one is the heavy and light truck, because like heavy light truck is not easy to install the electric.
Yeah.
Thank you.
Great job for the VIN group to create new cheap electric vehicles for everyone in Vietnam. Okay, can we have maybe a few questions from the audience?
Yes, thank you very much, our panelists, for your wonderful discussion. And now it's time for the Q&A session with a lot of questions to deliver to our panelists today. Yes, please, can our staff can assist the audience with the mic? Yes, please.
Oops. Here.
Yes, the mic is on.
It worked when he pounded on it.
So yeah, I'm coming to you.
Hello, hello. Okay, thank you for a very interesting opening. I've been in engineering for all my life, in automotive engineering, and I'm at VinFast here, so all part of the journey to try and reduce emissions and so on.
Hold it a little bit closer, please.
Yeah, sorry. So yeah, I think I'm here in Vietnam working for VinFast on the journey for electric vehicles and so on. But your question on one thing you would do is very interesting. I'd just like to extend that question a little bit more. So if you're going to say one thing that you could do, which we could do relatively quickly, but the will isn't there to do it, then what would that be? And just a couple of thoughts. Biomass burning is 10% of the emission. Why? Why is biomass burning going on? Why until recently did we use bunker fuel on global shipping, which was the worst emitter for sulfur, for example? So there are things maybe which are helping, and for example, new diesel engines are a lot more efficient than what we had before, and maybe on that journey, it plays a role. So what are your thoughts about that side of it? So moving away from what can be done, but it's going to take many years to do it, to what could be done relatively quickly. And I agree that getting electric vehicles onto the road is one solution, but that's only relatively, I guess, a small part for maybe the pollution in Vietnam. So that's my question.
Thank you very much for your questions. And so, moderator, who do you think that is the question is for?
I can.
Yes,
Sure.
Yeah. Thank you for your very interesting and very good question. You know very detailed the situation in Vietnam. So the first one, actually, I just introduced only three the most prioritized measure, but we have a lot of measures later that. One of the measures that for biomass burning, for rice crop burning, you see that a lot of emission. We have a lot of policy, the regulation that encourage people do not burning. However, some people, some farmers, they still burn, but hidden, like they burn at night, something like that. It's not easy to control them. However, that's very important. We should have a strong policy, stop burning. That I agree. And the next one for the shipping. Shipping, that's very important also. As from shipping in Ho Chi Minh City, around 10 to 15% of SO2 from shipping activity. And actually, we already have the carbon analysis in the marine organization. Or they already request a lot of countries to implement the carbon analysis to reduce the emission from shipping. In Vietnam, we think about that, and now we study a lot of different research to be implement that issue. So we will reduce the heavy oil for shipping activity, and think that's very soon we implement that policy. Thank you.
Thank you very much, Associate Professor Quốc Bằng Ho. And I think that we still have a lot of time when we are coming to the breakout session, so we can discuss more with our audience about the questions for Associate Professor Quốc Bằng Ho. And now we welcome many more questions from our audience. And yes, the man in blue, our staff assist him with the mic.
Can you just briefly detail what has been done to reduce air pollution in the past, like in Los Angeles from the smog in the 70s and 80s, and also in China? What measures were taken to reduce the air pollution?
Well, I mean, certainly in Los Angeles, the most important thing was the development and the forced implementation of the catalytic converter under the Clean Air Acts in the 1970s. I mean, Los Angeles had terrible pollution problems back in the 40s, 50s, 60s. It was incredible, horrendous. But that's because the vehicles were so dirty. So they were able to clean it up substantially by developing the Clean Air Act basically forced the car companies to implement catalytic converters on every vehicle, or they would face an enormous fine that would mean that the vehicle would not be viable to sell. That, of course, cleaned up Los Angeles in an incredible way. But now you face the problem that there's so many more vehicles that really the only way Los Angeles will have a truly clean air will be when all the vehicles are either electric or hydrogen powered. And actually, I believe Los Angeles is one of the few places where you can have a hydrogen-powered vehicle if you want to. I mean, personally, I'd rather go with the electric myself. But a lot of people are actually getting hydrogen vehicles in Los Angeles.
There are some. So I also share right now, electric vehicles are so much in the lead for any light-duty uses. There are some interesting applications for heavy vehicles, for trains, airplanes, industrial facilities, for truly green hydrogen. The problem is that most of our hydrogen today is reformed fossil gas.
Indeed.
And so it is not actually a life cycle winner. But I think you're exactly right in the 70s. And just maybe to amplify that, one of the interesting features is if you look back And you have to go all the way back to Carter, President Carter, when we were pushing to increase the so-called CAFE standards, the vehicle efficiency standards. Vehicles cleaned up remarkably rapidly. In fact, for a brief period of time, the US was doing almost as well as Europe. Those regulations were relaxed under President Reagan, and we saw the same level of innovation continuing, but none of it went into more efficient vehicles. It went into faster vehicles, heavier vehicles, and so that capacity to be creative is there, but if you don't direct it, it goes to other things. And so one of our challenges has been, I would say, keeping our foot on the gas, but that's no longer the right analogy. Keeping our foot on the electric accelerator. LA is right now the lead of something called the LA 100 plan, which is to fully decarbonize the city, including the industrial parts of the southern part of Los Angeles, and to do so in a way that will ultimately install for the US and Europe the largest electric vehicle charging stations powered by clean energy. But these are plans that unfortunately are going to be buffeted given what the new incoming US administration claims to want to do. We'll find out what they really do, but these plans are certainly under threat right now. As someone who resigned when Mr. Trump came in last time, we'll see how, has he learned to be more destructive than last time? We'll find out.
Thank you very much. Thank you very much, our panelists. Our distinguished guests, ladies and gentlemen, not only offline, but online platform from Zoom chat. We received a lot of questions from online. So now I will assist you to deliver the online questions for one of our panelists today, Professor Yafang Chen. So the question is, which specific atmospheric chemical reactions are most affected by emissions from transportation? And how do this reaction impact air quality at both local and global levels? So that's a question for you from our Zoom chat platform.
Yeah,
from
this
online
is
audience.
not only a good question, but also a challenging question. So I think according to our study, the NOx emission from the vehicle, of course, can contribute to the aerosol chemistry to form sulfate, but also the VOCs can form organics. So this is a very complex, and they also depend on the aerosol pH, and also depend on how much aerosol water you have. So in different degree of how much amount of aerosol waters, different reactions kick in and play their roles. So I think, that's my answer, is that it's a very complex system.
You can never ask an atmospheric chemist what is the one reaction that's really the most important, because the beauty of atmospheric chemistry is the plethora of reactions.
That I talk about, the NOx, it's more contribute to extreme. So if you want to avoid the extreme condition, for example, below, if your PM 2.5 below 100 microgram, which is already very polluted, this reaction may not be so important. It's only after you already build up some pollutions, and then it will accelerate. So if you really, you have a prediction that you are going to have that conditions, then of course you should immediately cut NOx emissions to avoid to go to such a very extremely high pollutions.
That's really interesting. So in the most extreme cases, you believe that NOx is more important than organics.
Yes,
that's really interesting.
Thank
and
you.
also just now, the heavy trucks, diesel cars, they produce a lot of black carbons. So if you really want to avoid the really severe haze in wintertime, you should immediately do that one also.
Thank you very much for your solutions. With that question, thank you very much, Professor Yafang Chen. And now, one more question from online platform is sending to Professor Daniel Kamen. So the question is, what technological innovations in battery storage and grid integration are critical for the large-scale adoption of electric vehicles in Vietnam?
So I would think that's actually a topic for a whole panel next conference. But I think that one of the things that we didn't touch on that this question I think is highlighting is that it's not just about getting lots of batteries in place. We know how to do that. The problem is we also need to do so in a way that's environmentally much more benign than we're doing now. So ultimately, the cell phones that everyone has in this room, unless you're really a super sophisticated material scientist, you probably have in your phone cobalt, probably mined in the Congo. That is today just about the most environmentally and human rights damaging material. We all use it. But there's new technologies. Lithium phosphate, for example, is a battery technology that VW and Tesla and some others have adopted that does not have cobalt. And so there are some material switches for mobile energy storage, for stationary work on non-metal flow batteries, zinc air batteries. There are some other technology pathways, and actually one of the neat features that I would say the solar field and the battery field share is there is really a very diverse set of chemistries we can look at, where we can think about materials that are not just recyclable, of which we do a bad job, but even disassemblable. And so you can think about material flows that are much more circular. It's something that China is working very hard on, a circular materials economy. Those things are going to need both the science and really serious regulation to move ahead.
For stationary batteries, what's your opinion about sodium? It just seems to have a lot of appeal to me. If you've got plenty of room, it doesn't matter if it's heavy.
Low energy density,
very
but
inefficient.
that's right. And sodium, very low cost. There's a lot of sources for it, so very attractive. I think I would probably bet that the demetallization into flow batteries that are non-metal might be more promising in the longer term, but these are kind of a leapfrog. And so the fact that we can make more environmentally and human rights just battery choices now means that we can, if we learn anything from the hydrocarbon fossil fuel age, it's that you need to think these are problems much easier to solve in the beginning than after the fact.
So when you say flow batteries, can you just explain physically?
Yeah, so it's a very weak sulfuric acid solution. You essentially slosh it back and forth between large tanks. It is totally impractical for mobile applications for vehicles, maybe for ships, but basically it would be a stationary battery. Now we have companies that are doing mechanical batteries. So you move blocks up escalators, if you will. When there's low-cost clean energy available, you bring them down, and those don't have any degradation over time. So you can do that in mass. We're seeing it in China, in California, in Sweden. Doesn't have to be water. It can be rock. It could be concrete. So there are other options that we need to push.
Thank you very much for your wonderful discussion with many opinions and solutions. And please kindly give a round of applause for our panelists today to wrap up this session. Thank you very much one more time for our panelists. And thank you very much for our online and offline audience, and especially our expert and distinguished guests to come with us in the field of air pollution and transportation sector. And don't forget that we still have the break time that our audience and panelists and prominent local scientists in the field can connect and network with each other. And I would like to invite all of you to join 3 different rooms for 3 assigned topics. And the session will last for 1 hour and close at 11:15. One more time, thank you very much, our distinguished guests and audience. And don't forget to follow and watch VinFuture Prize Award ceremony premiered on VTV1, Vietnam National Television on December 6, 2024. Thank you so much, goodbye, and see you this afternoon. Thank you very much.